Welcome to another video by Team Adcom. In this particular lecture, we will be discussing a question from the chapter Work Energy Power. So the question is, a body of mass 2 kg initially at rest moves under the action of an applied horizontal force of 7 Newton on a table with a coefficient of kinetic friction mu k equal to 0.1. That means we are having a body of mass 2 kg. There is a body of mass 2 kg. If this particular object is there on the table, we know that will be acting downwards. That means mass is m, means this will be mg. So the normal reaction will be acting vertically upward. So that is equal to r. So if you are applying a force that is in the horizontal direction, a force is applied means obviously the kinetic, the force due to friction, the frictional force will be acting in the opposite direction. Frictional force will be acting in the opposite direction. So we need to calculate work done by the applied force in 10 seconds, work done by the friction in 10 seconds, work done by the net force in 10 seconds. We know that if you want to calculate the work done, we need how much amount of displacement can be made for this particular block. How can we find out? So they're telling that the body of mass is starting from the rest. That means u is equal to 0. They're mentioning that the time is equal to 10 seconds. So our t is equal to 10 seconds. The mass is given as 2 kilogram. Mass is given as 2 kilogram, and coefficient of kinetic friction, that is mu k, is equal to 0.1. Mu k is equal to 0.1. So here, if you're considering, we know that S is equal to displacement is equal to ut plus half at square, ut plus half at square. We know the value of initial velocity. We know the value of time, but we don't know what is the acceleration over there. Here, when you're considering this particular kinetic friction, Fk force, kinetic force, Fk can be calculated as Fk is equal to mu k into R. Mu k into R. R is equal to mg. So we can, because R and mg are acting opposite to each other, therefore mu k into mg. Mu k into mg. So that is equal to mu k value is 0.1 into mass is equal to mass is 2 kilogram into acceleration due to gravity can be taken as 10 meter per second. That will be equal to 2 Newton. So kinetic force, not kinetic force, the frictional force, which is equal to 2 Newton. Here you can see that the frictional force will be acting opposite to that of the applied force. Why? Because whenever you are applying the force, the displacement will be taking place in that particular direction. The friction will be acting in the opposite direction. So we can calculate that the net force is equal to applied force. Net force is equal to applied force minus frictional force minus frictional force. So the applied force is equal to what? 7 Newton minus frictional force is 2 Newton. Therefore, net force that is equal to 5 Newton. Net force is equal to 5 Newton. So this particular body will be accelerated. Body will be accelerated due to this particular net force. So we can calculate that the net force F net, the net force F net will be equal to mass into acceleration of the object. Therefore, acceleration is equal to net force divided by mass. What is the net force? 5. What is the mass? 2 kilogram. That is equal to 2.5 meter per second square. So we got the acceleration is equal to 2.5 meter per second square. So now we can calculate the displacement, that is S is equal to ut plus half at square. Since it is starting from the rest, initial velocity is 0 into time is equal to how much time they are telling? 10 seconds. Time is equal to 10 seconds plus half into acceleration due to gravity is 2.5. Time square is 10 into 10. So 2.5 into 10 is equal to 25. 25 into 10 is equal to 250. 250 divided by 2, that is equal to 125 meter. Therefore, displacement will be equal to 125 meter. So we can calculate each case. What is the work done by the applied force? So the work done by the applied force, that is equal to force applied into displacement. What is the value of applied force? 7. What is the displacement? That is equal to 125. Therefore, 125 into 7, that is equal to 875 joules. The second question is, what is the work done by the frictional force? Therefore, the work done by the frictional force, that is equal to the frictional force multiplied with the displacement. Therefore, frictional force is how much? How much is the frictional force? Frictional force is 2 Newton. 2 into displacement uh, that is equal to 125. So that is equal to 2 into 125. That is equal to 250 joules. But we know that the frictional force is acting in the opposite direction as that of the applied force. So this will become negative, that is minus 250 joules. So the next thing what they are asking now, what is the work done by the net force? So work done by the net force, we can calculate in two different ways. Work done by the net force is equal to net force, force net into displacement. What is the net force? The net force is equal to 5 Newton. So 5 into 125. So the 5 into 125, that is equal to 625 joules. Or you can calculate in another way. Work done by the net force is equal to work done by the applied force plus work done by the frictional force. What is the work done by the applied force? That is 875 joules. Work done by the frictional force is minus 250 joules. Therefore, 875 minus 250, that is equal to 625 joules. So we have discussed all the three parts of the question. Hope the video is useful. If you need any clarification, do let us know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel, keep watching, keep learning. Thanks for watching. Bye.